One small step for man, one giant leap for mankind.
It's the one time of the year when about 4,000 space actors from all over the world come together and provide everyone with the latest in space information. This time, the 70th Annual International Astronautical Congress is kicking off in historic Washington, D.C., where we're celebrating NASA's 50th anniversary of going to the moon and hearing all about how we're finally going back. IAC TV starts right now. Hello and welcome to day one of IAC TV. I'm Sonia Gavankar, ready to bring you everything you need to know about this year's World Congress. Today we join everyone at the opening ceremonies, talk to a few different people about where the industry currently stands, and take an in-depth look at what the organizations and agencies around the world are doing to push the boundaries of space exploration. First, though, we speak with the local committee chairs of the 70th International Astronautical Congress. I'm now joined by Sandy Magnus and Vincent Boles, who are the co-chairs of the local organizing committee. Thank you so much for joining me. Thank you so much for having all of us here. What does it mean to have this event here in Washington, D.C.?
We were really excited to bring the event here in 2019 to the United States because of the 50th anniversary of the Apollo landing, and we felt like it was an appropriate way to celebrate such an amazing experience. And Washington, D.C.
It's a natural spot to have that. You know, we worked very hard to try to make the synergy of the 70th anniversary as well as the 50th come together, and to have it in D.C. where we knew our congressional decision makers would be here and accessible to the content, the people, the Congress, and get a chance to see firsthand themselves the U.S. space industry, all the contributions it makes, and how we fit in among the international community.
What can people look forward to? There are tons of things to see, but what do you think is the most exciting thing for people to look forward to?
It's a hard question to answer because everybody's here for a different reason, right? Some people come for technical deep dives, some people come for business, some people come to have a bunch of meetings with their bilaterals or multilaterals with their government, and some is a mix of everything.
For the space practitioner who comes, they're the ones who are going to selectively kind of look through this technical program and find the richness that they want. You know, on Public Day on Friday, you're going to have another group of people coming that are going to be looking for just the, hey, I want to see more, hear more about space, understand a few things, and so that's another dimension to the whole program as well. And so it's really a very enriched program. The technical program is really the heart of it, has been the heart of it for years.
But it's more than just technical. There's high-level policy. There are discussions about, globally what we need to do to work together to move forward. There are discussions about, what's going on in the private area, what the universities, what's academia doing, how do these ecosystems merge together, the policy, the law. So there's a lot of varied topics here. So it's kind of like a smorgasbord, right? It's a good chance for someone to, if they're used to focusing in one narrow lane, just kind of step out of your lane and check out one of the other lanes here and learn, broaden your horizons a little bit about what's going on in the space community.
That's a great way of putting it.
That's a very good way to look at it. And because you're in this nice venue where things are kind of in good proximity, you can kind of bounce from place to place pretty fast and see that. So I try to do that myself.
What excites you most about the direction of the space industry?
Well, from my perspective, things have changed a lot. We've gone from an era where things were driven heavily by obviously space agencies, large nation products. Today, if you look at where we are, we've got commercial space proliferating very fast. You've got individuals able to get access to space, do things with space-related activities and applications. So just the whole fact that we've now grown so prolifically over the years and are able to do so much more with so many more people, in and of itself is just wonderful. And then it takes on so many different applications and directions. So.
Yeah, echoing what Vince said, it really is all about the way the industry is changing to expand beyond only just governments engaging in a very proactive way. And what that's going to look like 5-10 years from now, who knows? But this is the community that's going to make it happen. And having these kind of conversations are going to lead to whatever that future is. And the industry is just expanding the engagement, both in the breadth and the depth as more countries come online and as people learn how to engage and do it in different ways. And it's really a blank slate. We don't know where it's going. There's just a lot of energy, and it's going to take time. We've been working on this transition for at least a decade. It's probably going to be another decade, and and it's just pretty exciting.
And one of the main drivers behind it, you see the young professionals. They are really excited now. It's almost like we have a renaissance in space like we had years ago during our era starting off. They are here in numbers. They are driving things. They are the ones that we see as the real future, and they really are making a difference. So that helps a lot.
Well, thank you for bringing all these people together. You've done some incredible work, and I know your work continues now that the event is finally here. Yes. Thank you so much for joining us.
You're quite welcome. Thank you for having us. Yes.
The opening ceremony is always an occasion to witness. For those of you who missed it, here's a sneak peek.
Welcome to the 70th International Astronautical Congress. Ladies and gentlemen, please join me in welcoming to the stage the IAF President, Jean-Yves Le Gall.
Good morning, distinguished guests, esteemed colleagues, and ladies and gentlemen. And it is a great privilege and a pleasure as President of the International Astronautical Federation to warmly welcome you to the 70th International Astronautical Congress.
Come on! Put your hands up! When you wish upon a star, your dreams can take you very far. When you wish upon a dream.
Words, let me close by saying that none of us can achieve what we want alone. It's time to redouble our efforts and not let anything stand in the way of what we can achieve together.
Whether it's going to the moon, Mars, staying in orbit, or deep space, technology allows us to reach new heights in space exploration. Let's take a moment to look at what organizations and agencies around the world are doing to push those boundaries.
Role of NICT is to verify cutting-edge space communication technologies, first in orbit. Our Space Communication Laboratory is located in Tokyo, as well as Kashima Space Center. We have about 50 members in laboratory, researching from device-level development to application-level experiment. NICT researchers in the past received the radio wave from Sputnik, and also we have demonstrated world first geo-to-ground laser communication. We are researching on space communication technology to realize broadband wireless communication for all users on ground, over the ocean, in the air, as well as in space. Our laboratory would like to promote practical use of these kind of novel technologies to the society.
WIN's aim is to establish high-speed satellite communication technologies. WIN's satellite was launched on February 23, 2008 by an H-2A rocket from Tanegashima Space Center of JAXA. WIN's project includes a variety of research related to mobile satellite communication, such as mobile Earth stations mounted on land, sea, and air. They are automatically detecting and tracking the WIN satellite for communication during experiment. WIN's transponder has a very wide bandwidth of 1.1 GHz. We succeeded in establishing 3.2 Gbps satellite communication. This data rate is the fastest in the world for satellite communication. WIN plays an important role in disaster countermeasures. At the time of Great East Japan earthquake of 2011, we provided communication support for the emergency fire assistance team.
We developed 5 kg class laser communication terminal on board 50 kg class microsatellites. It is called SOTA.
Small lasercom terminals will be the key to enable high-speed communication for all kinds of satellites. SOTA was the first lasercom terminal on board a microsatellite with less than 6 kilograms of mass. That allowed to mount it on a 50 kg class microsatellite called Socrates. SOTA transmitted a very narrow infrared laser beam, producing a footprint as small as 100 meters on the ground from a LEO orbit. QKD is the most advanced variant of quantum communications, and it will be a key technology to guarantee unconditionally secure communications. With SOTA, we demonstrated that space QKD technology is compatible with very small satellites. We are now working in the same line as with SOTA, trying to make the laser conterminal even smaller, to make it compatible with a CubeSat.
Engineering Test Satellite 9 is world's first hybrid high-throughput satellite using optical and RF frequencies.
ETS-9 is Japan's test satellite to prove next-generation satellite communications technology, planned to be launched in 2021. Our role is to prove the 100 Mbps class mobile communications for Ka-band and to verify the network control technology to prove the hybrid communication system concept. We also aim to realize the 10 Gbps class optical feeder link technology.
Many airlines have started internet access service using satellite communication. As the demand increases, it is necessary to increase the speed and capacity of satellite communications. The flat K-band antenna is an active electrically scanned array antenna with a wide range of beam scanning. This antenna can change the aperture size without compromising ease of mounting to aircraft.
With our Hikali project, we want to have optical feeder link, which will be 10 gigabit per second, mounted on ETS-9 satellite. The biggest challenge for an optical feeder link is the requirement to have real-time communication 24/7. For this purpose, we intend to use site diversity technique, so the Hikali payload will be able to switch between sites. Another big challenge is the link distance itself, more than 37,000 kilometers. For this purpose, we need to use very narrow laser beams to be sure that enough energy will reach both ends. With the success of Hikali mission, we believe we can turn a new page for space communications, where we can exchange the currently used RF feeder links with optical ones.
Our role is to verify first novel technology in space. We want to create new broadband communication services to all the users individually by using this technology. We want to have a worldwide collaboration because satellite communication is no border. Satellite cover all over the world.
It's a really exciting time to be in the space industry now because we've received a directive from the president to return humans back to the surface of the moon, something that hasn't been done for 50 years. And the more we can learn about our solar system, the more we can understand about our own planet and how it was formed, plus the desire to just understand, was there life in our solar system before? Will we discover that there's life in our solar system? Artemis is the program that's going to take humans back to the surface of the moon. It's a series of missions that will lead up to Artemis 3, but it doesn't stop there. There'll be Artemis missions beyond that, so we'll have a sustained presence at the moon, which will allow us to explore the moon, learn more about the resources that are on the moon that can take humans farther into our solar system.
The Orion spacecraft will contain other elements of the architecture like habitats, landers, ascent stages, to be able to stay in space much longer than what a single spacecraft could be. We learned a lot during Apollo. In the last 50 years, we've done things in low Earth orbit, but only about 24 have gone higher than just a quarter of an inch above a globe. This is the machine that will be able to take us further than we've gone before and build on all of the research that's been done to date. Orion technologies include heat shield, electronics, fault tolerance, propulsion systems, power generation, environmental control, habitation, waste systems, a galley. It's the entire city to keep the crew alive and comfortable.
Artemis 1 will be launched next year to orbit the moon and verify that our vehicle design works. Artemis 2 will bring crew out to the moon, verifying that we can take crew out to deep space orbit, keep them alive, allow them to work in space, and then return them safely to Earth. In the meantime, NASA's already starting with procuring the Gateway, They started with the power and propulsion element, along with the habitation and logistics outpost. The gateway is really important for us to explore the lunar surface. Astronauts can actually operate rovers on the lunar surface from the gateway. And then once the astronauts go home, we can continue to operate those assets through the gateway as a communications outpost from Earth. Not only that, the gateway allows us to further explore the lunar surface with humans at any point on the lunar surface. We want to explore all of the moon, not just one point, and the gateway enables that. NASA's really focused on going to the moon, but then also to Mars. They envision using the lunar gateway to bring humans on Orion from Earth out to the gateway, down to the lunar surface on the human landing system, but then also building up vehicles like Mars Basecamp that would take humans out to the red planet for the first time and then down to the Martian surface.
What this program means for society, going back to the moon and Mars, is learning more about what we know about the moon and the solar system around us, and what's happening on Earth, what's happened to Mars in the past. Significance of it is we've learned a lot with instruments and robots, but with humans, humans can think while they're on the surface of another planet, and they can discover things that you couldn't pre-program into a robot.
We're going back to the moon because it's what we do. We explore. But in addition to being able to explore, we're going to learn more about our solar system and how that affects and protects us here on Earth. And I think the other reason we're going back to the moon is to inspire. We want to inspire the next generation, and there is nothing more inspirational than going to space.
Space transportation is a very complex area and requires interdisciplinary approach to solve the problems and to gain new knowledge.
The work we are doing here is really important because there are still a lot of unknowns out there to make a flight mission successful and to further improve, for instance, payload to Mars.
We really are the interface between basic and general science and space engineering. We like to give engineers the tools and the information that they need to design a space mission with as little uncertainty as possible.
The DLR is a German aerospace center. It's the biggest engineering establishment in Germany with more than 8,000 employees. We in the spacecraft department are part of the Institute of Aerodynamics and Flow Technology with branches in Göttingen, Braunschweig and Traun.
The scientific focus of the department is the design of aerospace vehicles and the analysis of aerospace vehicles. The employees are usually aeronautical or aerospace engineers with a focus on fluid mechanics and flight mechanics.
We look at the complete spectrum you can imagine. So first of all, you have to launch a vehicle from ground. When you go into space, you have to control the spacecraft. And ultimately, when you want to come back to Earth, you have to re-enter the atmosphere.
The focus of the department is on reusable space transportation systems. Reusable launch vehicles requires high reliability, and to improve this, we use the tool of numerical flight tests.
We have experts in experimental methods and also in numerical modeling. And these people here are sitting together in the offices. They see each other every day.
AGG is the high entropy shock tunnel here at DLR in Göttingen, and it's a free piston driven shock tunnel which allows us to duplicate test conditions we see during re-entry of capsules, for instance, or during hypersonic sustained flight. 2, 1, and go. The combination of experimental work and CFD is very important. At the moment in the tunnel we have porous ceramic which is designed to control hypersonic boundary transition, and the CFD part on this would be to verify whether our experimental results match the predictions made in CFD, and if not, to improve the model. One of our most recent and also very exciting successes is the tests we did within the Hexafly campaign. We found a flow phenomena which was not foreseen by CFD before.
STG-CT is our test facility in which we can study the free expansion of a thruster plume emerging from a chemical thruster. This test facility is a large vacuum chamber that is equipped with a giant cryopump. We can pump even hydrogen and maintain a space-like background pressure. We're specifically studying plume spacecraft interaction effects, so we call that plume impingement effects. Predominantly that is concerned with contamination. Recently we've been conducting studies concerning lander and sample return operations, particularly in connection with the ESA mission to Mars moon Phobos and the NASA mission to Jupiter's moon Europa. This is the DLR high vacuum plume test facility for electrical thrusters, where we qualify actual space hardware for our customers. We also run a much smaller facility that we use for general research, basic research on, say, sputtering effects with electric propulsion devices. As space missions last a long time, on the order of 10 to 15, maybe even 20 years, we need to make sure that these continuously operating electric thrusters really survive during that period. We were involved with testing the thrusters and the technology for the European Commission LEO sweep project, removing uncooperative targets from the low Earth orbit by shooting an ion beam towards that target.
Here we are at the hybrid rocket engine test facility. Here we can test hybrid rocket engines with an oxidizer mass flow up to 8 kilograms per second for a time of up to 30 seconds. In recent years we have achieved a complete or nearly complete fuel consumption, and therefore we have increased the efficiency of the engines. For the design of our hybrid rocket engines, we use our software ARES. We need numerical simulation results, so we can calculate some complex phenomena like particle combustion.
Numerical aerodynamics is really important for spacecraft design because it allows us to look at the conditions we encounter for a space vehicle before we actually build it. So we use this to design the vehicle. We use it as input for thermal and mechanical loads. Because it's such a combined process, because the mechanical loads, the thermal loads, the subsystems, they all operate together, that you can't really decouple them. It would be really, really interesting if you have a model that can show how all these things interact.
Really, the ultimate goal is to develop a virtual spacecraft, to fly this spacecraft before it's really built.
To develop a virtual spacecraft, we need a lot of areas. The flow part, structural solver, then you have a flight mechanics solver, then atmospheric models, wind models, as well as gravitational models. And all of them come together to one big process. Depending on the computational power we have now available on our cluster, we are very near to a virtual spacecraft. Fortunately, the DLR has a high-performance cluster which has about 140,000 cores.
Once we are able to model a complete virtual spacecraft, we are able to significantly increase the reliability of future system. Space transportation is very expensive, and this significantly reduces the risk.
We try to find the way into the future. What is the most suitable configuration and how should it be launched and land in order to accomplish our missions in Europe?
It's rocket science, right? It's very hard to find another place where you can look at problems involving combustion, space propulsion that could have a bigger impact in the long run.
5G is going to change our lives completely. This shift is going to be once in a decade upgrade of a wireless system. And that's because 5G networks are designed in order to address highly complex services and applications, such as the support of millions and billions of interconnected devices, what's known as massive machine communication. The only problem is that only 25% of the Earth's landmass today is covered by cell towers. The rest of the land, the oceans, have no coverage. We cannot use traditional legacy satellites in order to address this problem because they are too expensive and far away from Earth, introducing delays and latencies. For truly global 5G massive machine communication to be enabled, a truly low latency of only a few milliseconds is a must. And at OQ Technology, we try to address this problem by enabling 5G massive machine communication all over the world, from North Pole to South Pole, using a constellation of nanosatellites, and by pushing down the latency into fiber-like speed using low Earth orbits, which are hundreds of kilometers away only.
At OQ Technology, we think that an interconnected and intelligent world implied worldwide connection and sensing. We want to monitor assets in remote areas. For that, our solution will be low cost and enable low power consumption devices. It will also have modern features such as state-of-the-art security. The system will also be scalable and, in the full deployment phase, enable low latency access to the global network in a seamless manner.
Today, to send 1 megabyte of data from remote and rural areas, it can cost sometimes 2,000 times more than in cities and urban areas. And this is because of the large cost of the infrastructure, of large satellites, giant antennas, and bulky user terminals. We want to change this. So a user, if he or she uses a cellular IoT device inside a city, they can still use this anywhere in the world seamlessly using our satellite network with a simple software upgrade. So this means for consumer and industrial customers, they don't need to deploy two types of networks, terrestrial and satellite, but only one wireless solution, which in the end reduces their cost of ownership and operations immensely. Industry 4.0, like the energy sector, for example, oil and gas, upstream and midstream applications, maritime applications, predictive maintenance, SCADA applications, smart metering, mining, but also especially with respect to transport and logistics with fleet management and tracking of critical assets.
There are exciting new challenges. The main challenge is the scalability of the system, both in terms of deployment and performance. We are working on a software-defined radio type of system in a first phase where we'll be able to upgrade a satellite on the fly the same way you would upgrade your phone or your computer. In the deployment phase, we'll have our own dedicated payload. There are also specific challenges due to the non-terrestrial nature of the communication systems. For this, we are built upon the most advanced and non-proprietary technologies developed within the 3GPP consortium. For example, it could be 4G LTE or 5G. There are also communication problems such as the challenges of synchronizing and decoding the signal sent from a rapidly moving satellite. For that, we specifically tailored algorithms that can track and successfully communicate with LEO satellites.
We are supported by the Luxembourg Space Agency since 2017 under the National Space Program Lux Impulse. So we started with a feasibility study to discover the market, find the right technology that fits this market, and to figure out how we make 5G works over low Earth orbit satellites. And that concluded successfully, and then we moved into the phase of developing and testing the technology in orbit, like with the Tiger mission and the upcoming MaxSat mission.
The Tiger mission is an experimental success. It has permitted us to go beyond system simulation and validate in practice via experiment that 5G IoT could be successfully used in conjunction with software-defined radio and specifically tailored algorithms. It is a first step toward our global mission, which is to connect everywhere, everything with low latency, low cost, and low power consumption devices.
Yes. Our future vision is to make every cellular device speak the same language as satellites and to help mobile operators extend their 5G massive communication beyond cities into rural and remote areas globally through space.
There are a few companies that have been at the forefront of space exploration for a long time. Next, let's hear from a few about how they're supporting NASA with Artemis and what they think it means for society as a whole that we're going back to the moon and beyond. I'm now joined by Lisa Callahan of Lockheed Martin. Thanks for joining us. Tell me what Lockheed Martin is going to be doing to support NASA going to the moon in 2024.
Well, thank you. I'm really excited to be here. So Lockheed Martin is really excited about the Artemis program that NASA is going to send the first female and the next man to the surface of the moon. And part of the role that we play in that is through our program called Orion. Orion is a deep space spacecraft that will take humans from Earth to the Gateway and then return them safely. Our Artemis 1 program is in full swing down at the Cape right now, and we were recently awarded a contract for production for Orion, Artemis 3 through 8. And Artemis 3 is going to be that space vehicle that will take the first woman and the next man to the Gateway and then on to the surface of the moon.
That's so exciting.
We're really excited.
What does it mean for society that we're going back to the moon, and why is this even important right now?
So we've explored for our entire lives, and exploration, space exploration in particular, is critically important to the society. I always say that we explore to discover, to protect, to innovate, to connect, and to inspire. So we explore and discover things about our solar system that can then help us to protect our planet here on Earth. We innovate. The technologies that come out of space are wonderful, and they are helping us here again on Earth. And then we connect through what we're doing with space exploration. If you think about the International Space Station, 18 countries are joining together and collaborating. And I imagine to get onto the lunar surface and then onto Mars, it's going to take an even more expansive collaboration worldwide for that. And then lastly, it inspires. Who doesn't want to be an astronaut? So it's inspiring the next generation, the generation that will be the Mars generation, is why we explore.
That's really exciting. Yeah. Short term, what can we look forward to from Lockheed Martin?
Well, I think you'll see from Lockheed Martin that we're going to continue to be really passionate around space and space exploration. And so we'll continue to expand our partnerships across industry as well as across nations in supporting that, so that we can make this generation of going to Mars a reality.
Excellent. Thank you so much for joining us, Lisa.
Thank you so much for having me. I appreciate it.
I believe it'll be a great opportunity to lessen our space exploration for Earth resources. So the gas station on the moon sounds like a great idea in order to keep a sustainable exploration effort going.
Going back to the moon is exciting for the entire world, not just for America, for everybody. We heard this morning, we did it, that the American astronauts did it themselves, but heard that everybody else had done it, that participated. As one of the lawyers that looks into the legal questions, international arrangements, I like the legal rules, but the challenge and the possibility of exploring things even further beyond, it's all good.
The thing that excites me the most about going back to the moon is the fact that we finally have women involved in the program. It's so important to have representation in such an international industry such as the space industry.
Recently, we had one mission, Chandrayaan 2. It excites me because we have, historically, through our relations, we are connected to moon.
The fact that we're going back to the moon is really just a signal that we're progressing once again in space flight. Yes, we've already been to the moon, but for the last, well, my entire lifetime, in fact, we've just dithered back and forth. Are we going to Mars? Are we not going to Mars? The fact that we have an achievable goal that we're working towards right now, which leads to larger goals in the future, tells me that we're going places again. And it means that in my lifetime, I'll see a great achievement once again.
I think the moon is a wonderful step towards moving on within our solar system. So it makes sense to establish ourselves there before moving on. I don't really see it so much as us going back to the moon as just preparatory steps using the moon to go further.
That's it for today, but remember, we'll be back each day of the Congress with much more exclusive material. We'll see you tomorrow.